Hello everyone. Welcome to Embedded Laboratory. If you are following my YouTube channel or my blog, you might have seen a post or video based on displaying temperature graph using STM32 microcontroller and LVGL graphics library. In today's video I will show you guys how to do the same thing using ESP32 and ILI9341 display controller and using the LVGL or Light and Versatile Embedded Graphics Library. First, multiple rectangles of different colors are shown on the display for 4 seconds. Then, a simple application of red, green, and blue color mixing is shown on the display, where moving the slider will change the color of the rectangle. If all slider values are set to 255 value, the software state machine moves to the next state of displaying temperature and humidity values on the chart. These temperature and humidity values are received from the DHT11 sensor and stored in an internal buffer, which is then used for plotting this data on the chart. You can download this project from the links given on the project page, or you can watch rest of the video to understand how I developed this project. I am using Platform IO with Visual Studio Code, but the same code will work on Arduino IDE also. As a next step, create a new project based on the ESP32 development kit which you have and save this project in your preferred location. Once the project is created, we have to install the 3 libraries. First one is the DHT11 sensor library. Then the TFT SPI communication library. And the last one is LVGL graphics library. All these libraries can be installed as shown in the video. Once all libraries are installed, we configure these libraries as per our project requirement. With Platformio, the libraries are installed inside the .pio folder, as shown in the video. First we will configure the TFT SPI library. For that, we have to open the user setup file and update it as shown in the video. Here, we are updating the correct connection information in this file. And don't forget to enable the touch chip select pin, else the software can't communicate with the touch controller present on the board. And also updating the speed of SPI communication to 40 MHz. The next step is to configure the LVGL library. A template file is already available for this configuration. We will copy this file and paste into the root library directory. And then rename this file to lv_conf.h file. The code inside this file is disabled, and to enable it, we will replace this 0 with 1. Now, do the changes as shown in the video, and the configuration of LVGL library is done. The next step is to calibrate the touchscreen. But this is not a complex topic. Thanks to the Arduino community, we already have an example project available with us to calibrate the touch controller. With Platform I/O we will again search for the TFT-SPI communication library, and in the Examples tab, we will search for the project or example names, Touch Calibrate. I will copy this project into the main.cpp file. In case you are using Arduino IDE, you can go to Examples, then TFT-SPI, then Generic, and then open the Touch Calibrate project, this project, and the project which I opened in the Platform I/O are same. Now, let's build this project. Okay, we have couple of errors, and now we have to resolve them. The one error is related to missing Adafruit sensor library, and the another error is related to touch calibrate function. Adafruit sensor missing library can be fixed easily by installing the library from the library menu. And this touch calibrate error can be fixed by adding the missing prototype at the top of the program. This issue will not occur with the Arduino IDE, but with Platform I/O, we have to update like this. Now, let's build the project again. The build looks fine. Let's program this and calibrate the touch screen. Once programming is done, open the serial monitor, because the calibration data will be printed on the serial port. As shown in the video, press the corners on the TFT and follow the instructions. Once all corners are pressed properly, the calibration data is sent to the serial terminal. And this data will be used in our program. The most complicated and problematic part is done, and now it's time to update the application code. The project files are already available on GitHub, just download these files and use them in the project. I have pasted the content of the main.cpp file from GitHub into our project. The next step is to create another file main.h in the same folder, or you can create this file in the inc folder also. Again, I will paste the content of main.h file from GitHub to our project. The next step is to create another file displaymanager.h in the same folder, and I will copy the content of this file from GitHub. Now, I will create the last file of this project, which is the displaymanager.cpp file, and again I will copy the content of this file from GitHub to the project. Let's build this project to see if we receive some errors or not. The project builds fine. Let's upload this project into the ESP32, and it will work fine, as we have seen at the start of the video. The most complex part of setting up the ESP32 and ILI9341 with LVGL is already shown in the video. I am not going to explain the source code in this video, as this will make the length of this video very long. But the code is extensively documented, and I am sure you will not face any problem. But in case you face some problems in understanding some piece of code, let me know in the comments section. If you also need the second part of this video with explanation on source code, please let me know in comments section, and I will prepare that. If you like this video, press the like button and subscribe to this YouTube channel. Thank you.